So here we go. Let's start off.
Set.
Safa Paul ist der schnellste aus den Blöcken. Jetzt kommt er. Und jetzt ist Usain Bolt nicht zu halten. Nein, er gewinnt. 9,58 Weltrekord. Ein Wahnsinn.
The first problem is Jamaican sprinter Usain Bolt. He shocked the world when he ran a 100-meter dash in 9.58 seconds. Determine his average speed for the race. Now, remember what our average velocity was. Our average velocity equation was v equals the change in displacement over the change in time. This is going to be distance for the speed. So speed is the change. Speed is the change in distance over the change in time. So for this problem right here, we need to know what the change in distance is. So he's going from 100 meters. Let's make this absolutely correct here. It's 100.00 meters that he ran. That's the distance he ran. And the time it took him was 9.58 seconds. So you divide those two. This is a very easy problem. You're going to get an average speed of 10.4 meters per second. And notice I used 3 significant figures here. That's because there's only 3 significant figures in that measurement right there. We're going to talk about that more and more and more. All right, so that's problem number 1. Let's go to problem number 3. We're skipping over problem number 2 because I don't want to give you all the answers. So here we go. Let's see. Just had that editing window up there. What do I do? Let's do this. Okay. Let's use a different color now too. Let's use blueberry as a color. So the question, here it is, I'll pull it up for you. Number 3, in a qualifying round of the 50-yard freestyle in the sectional swimming championships, Samantha got an early lead by finishing at 25 yards, the first leg in 25 yards in 10.01 seconds, and then finished the return leg, which is a 25-yard distance, in 10.22 seconds. Now, we're using the weird units of yards here, not meters. They are weird, and it's about, I don't know, it's about a meter for every yard. A yard is a little bit less than a meter. But we're going to use that as our unit here. We're going to continue with the units of yards. And one thing that you need to know when you're doing this problem is that when you're swimming, you're going in a straight line forwards, and that's the first leg, and then you're going back exactly in the same straight line, if I could do that, right there. 25 yards both ways. So you're going 25 yards in this way, so it'd be 25.00 as it said, yards in that direction, and then you're going back 25.00 yards in the other direction over here. So we want to know the first part of the question says, determine Samantha's average speed for the entire race. Speed here is a key word, speed. So speed is the total distance that she traveled over the total time. So the total distance that she traveled was 50.00 yards, and the total time it took her to do that was 10.01 seconds plus 10.22 seconds. If you add these up and you divide 50 by that, you're going to get as an average 2.47, that's a point, 2 yards per second. All right. That's the first part. That's A. Now let's do B. B just wants to tell you, or what is it? B says, determine her average speed for the first 25-yard leg of the race. Let's do that. Let's do it. So the first 25 yards, it took her 10.01 seconds. That's, again, a decimal right there. So the change in the distance over the change in time for the first is going to be 25 yards over 10.01 seconds, because that's how long it took her to go to the first leg. Notice that the first leg she did faster than the second leg. It took her more time to complete the second leg going backwards, which makes sense because you might be a little bit tired. Here we go. We take this divided by that, and we're going to get 2.498 yards per second. And does it make sense that this number is larger than this number? It should, because she's going faster in this leg than she is overall as an average speed. So this number right here should be faster, should be larger than that number. So this is 2.498, that's 2.472. It makes sense to me. Let's look at the last part. The last part is determine Samantha's average velocity for the entire race. This is so easy. I can't believe I'm giving you this problem. Oh my God. Because for velocity, our average velocity is the change in your displacement over the change in time. The change in the displacement is, oh man, it's just 0. And the time, it doesn't matter what the time is because you didn't go anywhere. Your average velocity is 0 yards per second. And you can put as many zeros as you want to behind that. For our case, I guess it's going to be 4. All right, that's the third problem. Let's go to number 5. 5's got a new idea. Let's see here. Let's delete this. Okay. Number 5. This problem is a new concept. The change in velocity over time. Oh my God. During this annual shuffleboard competition, Renee gives her puck an initial speed of 9.32 meters per second. Once leaving her hand, the puck slows down at a rate of minus 4.06 meters per second. Okay, so those of you who don't know what shuffleboard is, let's see if I can pull up a link here. Shuffleboard. Shuffleboard. Oh, lots of old people play it. I used to play this.
I'm Billy Babe, 25-time world champion shuffleboard player.
Whoa, he's a world champion. Oh my God. Let's turn this down a little bit. Okay, so you see these are little pucks right here, and you slide the puck down and you try to get to these. This is 3 points, that's 2 points, that's 1 point. You try to slow it down and stop it at this distance right here. So you'll see him doing it, and you can knock other people's pucks out of the way, and he wants to stop right. Ow! Almost stayed on, but now he lost that point. Okay, and they like it. So that's what shuffleboard is. Shuffleboard is that little puck. You throw the puck all the way down on that wooden surface, and it slows down. All right, so what does this mean for our problem? So you got some things here, some values. You've got 9.32, and you got minus 4.06 meters per second per second. It's a brand new concept. But our initial velocity, and let's use a different color here. Let's use a different color. Let's use magenta. Let's use magenta. Here it is. Our initial velocity, which we use a U for, don't ask me why, is 9.32 meters per second. That's our initial velocity. Now we're slowing down. We are slowing down at a rate. So the slowing down rate, which I'm not even going to call it acceleration yet, even though I just said acceleration, that's what it is. I'm not going to call it that, is minus 4.06 meters per second every second. It's weird to say it like this. There's another way we describe this with units. It would be minus 4.06 meters per second squared. You can do that. But we're just going to use this right here, meters per second per second. That's how, so every second, this is how slower it gets. So the puck starts over here, and it starts off with an initial velocity of 9.32 meters per second. And then let's say it goes, and then after 1 second, it's now 1 second in the future. What's its velocity? It's got to be minus 4.06 from where it started from. So its velocity now is 5.26. 5.26 meters per second. Point. All right, and go for another second. Trying to make this. This is second. Okay, so another second in time. That's the same puck, sort of. And it's now another minus 4.06 meters per second. So its velocity is now 1.2. 1.2 meters per second. And then at some point in between that last second, it's going to stop. So we don't know at what time. We want to know what time. At what time does it stop? Does the puck stop? Okay. So we want to know when it gets to 0 meters per second. So let's try to figure this out. All right. So the way that I'm going to do it is a little bit strange, I guess. We could do it like this. I'm going to do it kind of like a just a seat of the pants kind of reasoning to figure this one out. So let's say 9.32 is our velocity, and then I'm going to say, all right, well, minus 4.06 times the time. This is meters per second, and this is going to be seconds over here. Okay, so whatever this x is, that's how many seconds have passed. Okay, so let's see what this looks like. So 9.32 meters per second minus 4.06, should be 06 here. Okay, meters per second times, let's say, 2 seconds. What's this going to be? Well, this is going to be 9.32, and let's block this off. Okay. Actually, this is going to have to be a little bit different. This is going to have to be seconds squared. Sorry about that. It's going to have to be that. That's going to be our slowing down rate. So here, we're going to multiply these two numbers together, and it's going to be, our result is going to be 1.2 meters per second. Because what we do is we multiply this by 2, and we subtract it from the 9.32. And it's what happened over the 2 seconds that we saw before. So after 2 seconds, that's what we have here as our x. Let's make that a different color. Let's make the x a red color. So here's our x. And this is our x right here, our 2 seconds. Okay, so after 2 seconds, 2 seconds have passed. Now we have 1.2 as our answer. So this is 1.2 seconds. All right, so now what we want to do now is we want to figure out what x, for what value of x, does this final answer over here equal 0. Well, that's pretty easy. Now we just set this equation up. So it's going to be 9.32 meters per second minus 4.06 meters per second squared times, let's use x here, I'll cover it again with red, equals 0.